bean scopes in Spring, and then we will develop our first Spring Boot app. So this is our agenda. First of all, we will talk about what is meant by bean. Bean is nothing but an object created and managed by Spring containers. Because our container doesn't want to recreate this app object every time when user needs it or programmer needs it. It will just create one copy of these objects, and whenever any programmer or any class needs this object, it will provide that objects. So as we discuss ahead the scope of bean or all those things, you will get to know how it will manage these objects and how it will return or dependency inject those objects in particular class. First of all, we need to discuss what are the different Spring containers we have. So Spring containers, we have two Spring containers. Two containers are there. First is application context container, and second is, I need to search it, it should be some web related, Spring containers. You can see the what are the functions of Spring container, Spring IoC containers, and all those things. Application context, bean factory. I got it. So another container is bean factory container. This is old type of container and legacy container. Okay, so we mostly use application context container. It is new and mostly used container, and it is better to handle lots of objects and manage all the dependencies. So we use normally application context container. So let us see what are the functions of container. As we see on Google, it says, see key responsibilities. Bean instantiation. The container creates instances of beans defined in the application's configuration. So object creation is the main function of containers, and it creates object or instantiates all the objects that are present in class paths and needed by our functionality. Then second function is dependency injection. After creation of objects, it will inject those objects to all the classes that needs those objects. So it resolves and injects dependencies between beans. This means that instead of a bean creating its own dependencies, means by using object creation only, by using new operator, The container provides them, promoting loose coupling and easier testing, because container directly provide that object, and we do not need to create it by new operator, and by not creating it by using new operator, it becomes loose coupling and it becomes easier to testing also. Then third, bin configuration. The container reads configuration metadata, that is XML annotations, Java based configuration, to understand how to instantiate, configure and assemble the bins. So in configuration class we can define any method that we want to create bin of, and it will return object, return that objects that we want to create it as a bin. So any object that is not automatically created as a bin by a Spring Container, we will define it as a bin configuration class by using @configuration annotation, and we will define that method by using @bin annotation. If we want to rename that method, it will by default take that method name as a bin object in Spring Container, but we can change that name also by using @bin annotation, and in bracket you can in double quote write any name that you want to identify that bin method with or bin with. And then last but not the least, bin lifecycle management. So it manages the entire life cycle of bins from creation to destruction, including calling, initialization and destruction callbacks. So here it gives the summary of everything whatever we have discussed. Developers define their application components, bins and their dependencies using various configuration mechanisms. The Spring IoC container then uses this configuration to scan for components. Components can be components can be defined using @controller, @service, @repository, @component, such type of stereotypes of annotations. Then it will scan for components. Spring IoC container then uses this configuration to scan for components. First it will scan all the components, then instantiate the necessary objects. All the components those are defined by our programmer. It will instantiate the necessary objects, wire them together by injecting their dependencies. Now it will wire each and every object with its dependency, which class it is needed. It will inject that objects and manage their life cycle. So this approach significantly reduces boilerplate code, it enhances modularity, because we do not create any new object by using new operator, and simplifies testing by allowing components to be developed and tested independently of their concrete implementation. So this is how our containers work. Okay, so this is very important functionality, and it is a core concept of Spring framework. Okay, that is why it is very popular, and this reduces the lots of boilerplate code and programmers workload also. So it reduces efforts and increases the productivity of programmers. Also enhances the modularity of the application. Now we have talked about functions of container. Now we will talk about bin scopes. There are two types of bin scopes: common scopes and web related scopes. In bin scopes there are also two types of scopes. One is Singleton, other is prototype. In Singleton scope, only one instance of your bin is created and managed by your Spring container. But in prototype scope, multiple instances can be created if we guide our container. So it will create multiple instances of our bins. Now we will talk about web related scopes. There are three web related scopes. We have request, then session, and third web app. So here a request scope tells our container that create a new bin for each and every request. Let me see once it will create web specific. Okay, see, this is present here. In request scope, it will tell that a new instance of request scoped object is created for each incoming HTTP request. Okay, for each incoming HTTP request, it will create one new instance and it will be destroyed once the request completes. So any incoming request, for any incoming request, it will create new instance of object, request scoped object, and after that completion it will destroy that object. So visibility of such object is accessible only within the context of that specific HTTP request. Means until and unless that request is alive and working, the visibility will be available. And use cases of such type of request scope is storing the data that is relevant only for duration of single request, such as form data submitted by user or temporary data needed for rendering a specific page. Second, we need to talk about session scope. Say in session scope, a single instance of session scoped object is created for each HTTP session. Here, for each HTTP session, one instance of object is created. It is required for complete duration of the session. So it will be destroyed when the session expires. So it will be visible when object is accessible across multiple HTTP requests. The visibility of the session scope. The object is accessible across multiple HTTP requests from the same user within their active session. It will be accessible to multiple HTTP requests within their same session. Until and unless session is working, it will accessible to each and every request. Use case can be storing user specific data that needs to be maintained across multiple pages or interactions, such as user login details. When we log in into particular website, until and unless we do a lot of working and access each and every page, that login credentials are needed to access each and every page. So such login details should be saved in session form of scope. Then shopping cart contents. Whenever we shop on any e-commerce website, shopping cart should be visible to each and every page. So it should not be destroyed within any particular HTTP request, but it should be open or it should be accessible until and unless our session is running. And then third scope is application scope. Single instance of object is created for the entire web application. Okay, and it will remain active until and unless our application is running and it is yet to shut down. So for one application scope object is created and it will be run until and unless our application is shut down. So visibility is the object is accessible to all the users and all the requests within the application. Any user can access it, all the requests can access it, such as a application level counters. Means lot of the time we need to use cases can be application level counters, or storing global application wide data, configuration settings, or shared resources that are needed by all users and part of the application, such as database connection pools or application level counters or languages. Such type of use cases can be used for such application scope level objects. Or application level counters are needed to count the visitors for particular website. How many visitors visited to that website in particular day or particular week or particular month. So to count that number, we need to have such a application level counters. So these are the scopes of Bean. Now we will go ahead with our first Spring Boot application. I will first show you how to create our first Spring Boot application with the help of Spring IO website. So we will go here, we will go on spring.io.starter. Here you will see Spring Initializer. Okay, you just need to click here. Now you will see this window where you can select different project build tools, languages such as Java, Kotlin, Groovy. Project build tools can be Maven, Gradle Kotlin, Gradle Groovy. Then you need to choose Spring Boot version, which is currently ongoing and which should be latest. While you should take care while choosing particular version. So according to version, functionality will change, and different classes or functionality can be depreciated also with new version. So you need to choose very carefully which version you are working on, which version you want. If your project is legacy project, then you need to choose previous versions, and depending on functionality. Now you have to select group ID. Group ID is nothing but your company name with the functionality it does, such as com means commercial, org means organization, edu means educational. So you can choose it. Artifact is nothing but a project name, the name that you want to give to your jar file after the project completion. When you build your jar file, when you compile and test that jar file and create .class files, then what name you want to give to your jar file, that is nothing but artifact. Okay. Then description, you can describe your project as anything, like a demo project for Spring Boot, demo 1 project I will say, and I will give artifact name as a demo 1. And package name, it is already given, com.example.demo. I will keep it. Okay. Then most important thing you need to do is select the packaging. Packaging can be jar, packaging can be var. Okay. But here we will select jar because our application is Java. Java related application is there. And finally we need to select the version of Java programming language. Latest 17 version is going on. But currently 25th version is also came in market, but it is very latest version and we are not going to work on it. We are working on legacy projects also, and most of the time right now in market Java 17 is working really fine and it is used by most of the projects. So we will go ahead with Java 17. Now in this section you can add new dependencies. Whatever you need, whatever the programs you need, it will add those dependency. So you do not need to go to Maven repository and select that XML configuration dependency and put it into your pom.xml. You can directly add all the dependencies from this section. So we want to create web application. So we will go ahead with Spring Web dependency. So first we have added Spring Web dependency. Then we will go ahead with logging also. I want to have logging, so I would like to go ahead with logging dependency also. So I would go ahead with Lombok dependency. Then for continuous upgradation and execution of the program, we need to have dev tool dependency. So it is starter dependencies. It will help developer to reduce his efforts and increase the productivity of the developer. So I will go ahead with these three dependencies only, and we will just call our web application with Postman, and we will check whether our functionality is working properly or not. So here I will press generate project. Okay. Now it has created one zip file. We need to extract that zip file, and I will go here. We need to extract that zip file. Extract all. We have extracted our file. Now we need to import that file into our IDE. Okay, so we will go here, new Maven project. No, this is not the case. Import existing Maven project, browse, downloads, demo, and select that project. Why it is not taking? Where is our pom.xml? One minute. How it created? Oh, we did one mistake. We haven't choose Maven. So let's choose Maven and create our file. Let me delete both of the file, create it again. Now we will go ahead with Maven. Okay. Now our Maven project is ready. We just need to extract that project. Extract all. And now we can definitely import this project here. So import existing Maven project, browse. I will go with the demo, and yes, we have got our pom.xml. Finally finish. This is our demo 1 app. Okay. See, you can learn lot of things by seeing this feature only. Can you see our app? This is demo app. How to see? This is our demo app. Okay. Let me just so see, you can see it boot here. So it is showing that it is Spring Boot project. Then DevTools, it shows that it has a DevTools dependency with it. And this is our project structure, Maven project structure, where source dash main dash Java. Here you will put your Java files. Okay, it will automatically create one file, that is demo application. Then it will have source dash main dash resources. Here you will put all the resources, static resources, template, .html file, .css file, anything, application.properties file in resources. any document related files. And then this will have test related documents, test related Java files. Here you will do a unit testing. So this JRE system library will show you all the Java related, Java runtime related jars, okay, that is required to run your Java files. And this Java SE 17 shows that 17 version of Java is used. Then it will have Maven dependency, that whatever we have added in dependency in pom.xml, all the files related to all the dependencies will come here. Then we will have source and target, all these folders, but most important file in this project structure is pom.xml. You can see this is how we need to check it. See, one important tag is that project will, this is ended here, project tag, and in project tag each and every functionality will be there. Means each and every tag is resided in project tag only. You will have dependencies, you will have properties, you will have dependencies. All the dependencies will be under dependencies tag, and you add dependency with dependency tag in dependencies section. Okay, so these are nothing but group ID of your project, artifact ID, then version of your project also given, and name of your project is also given, description is given here. So all the related documents or details are given here. So you just need to pick right kind of dependencies and add all those things here. You can see we have added boot related dependency, started web, boot dev tools, then project Lombok is also there, and started test is automatically given when we add web related dependency. It will come with it, okay, directly. Then when you see the build tag, you will have a lot of plugins with it. Different plugins can be added with our project. So these are the functionalities we need to work on. We need to master this each and every section to work with Maven project. So it will it will avoid lot of efforts by you if you learn each and everything properly. Now we will write our application functionality. This is a main class, okay. This class will run our application. This class will have Spring Boot Spring Boot application annotation, which is a combination of auto configuration and component scan annotation, okay, which is nothing but a control O. Spring Boot Spring Boot application, it is main. Our application will start from this main method, and it will scan each and every configuration, and it will also enable auto configuration also. So I would like to go ahead with it. Spring Boot application annotation is a combination of, see, it is a combination of auto configuration, enable auto configuration, component scan. See, configuration. This annotation indicates that the class declares one or more bean methods and may be processed by Spring Container. This is a combination of 3 core annotation, that is configuration, enable auto configuration, and component scan. It will scan each and every component in your application, such as @controller, @component, @service, @repository. Here it will enable auto configurations. Based on class path, dependency, and other settings, Spring Boot automatically configures many aspects of your application, significantly reducing the need for manual configuration. Means by checking your class path, Spring Container will automatically create beans that will be required by your application, or that is mostly used by your application. In with configuration annotation, lot of methods will be given as a bean method, and that will return that object that we want to create as a bean. So with configuration annotation we will define that beans, and our application Spring Boot Spring Boot application will scan those bins and create objects and put it in a container. So this is what nothing but a Spring Boot application. Now I will go ahead with our application development. I will create one package. I will create one class such as a demo controller. Okay, and it will be the part of controller package. Now we just need to here we will just take one simple example. It will return string to our call. Okay, we will define one method, public hello world. Public, it will return string message and return welcome to Spring Boot. This will be our message. Okay, now we just need to use our annotations. REST controller. This will define our class as a REST controller, means it will function like controller as well as it will return some response. So REST controller is the combination of controller plus response body annotation. So it tells our IOC or container that it will definitely return some string value or any response body. So this is nothing but a definition of our class. We defined it as a controller which will return some response body. Now we need to define our method with get mapping. Get mapping for get request of the HTTP. Whenever we call our method with the HTTP get request, it will definitely hit this method and return the welcome string method. So now we will save these changes. We will run our application and we will call this method. Okay, by default our application will run on 8080 port. Run as Spring Boot application. Now we will see the console. See guys, you can check the messages here. First message is starting demo application using Java 17, means version of your Java, with PID means process ID. It will have a unique process ID every time. And it shows the target classes, means your classes created, where your classes has been created after compilation. Then these are nothing but a log message. You can read info. These are nothing but log messages. Second message is no active profile set, falling back to one default profile default. There are different profiles. We will definitely see those profiles in future. DevTools property default active. Set spring.devtools add property to false to disable. Means we have added DevTools dependency. It will automatically run our server whenever we make any change to our program. Then next message is Tomcat initialized with the port 8080. So 8080 will be the default port for Tomcat application server. Then starting service means starting Tomcat service. Then starting servlet engine. Servlet engine is very important. That will definitely take each and every request and process each and every request. Initializing Spring embedded web application context. So you can see here container is initialized and here web application context is given. Root web application context initialization completed. This gives the time of initialization. Now Tomcat started on port this and context path is this. Means with your local host and with this you can directly call our method and started demo application within this much of time. So you can, this has already calculated time of our application running starting. So we will use browser to call our method. This is our URL. We will call this URL right now. And see guys, we can see the message, welcome to Spring Boot. We have called it from our browser, but we can call it using Postman also. So I will start Postman and I will call it. Okay, Postman is here. We can definitely get response from Postman also. Just put this request here and get request is there. See guys, our response is coming, welcome to Spring Boot. So this is how we can start with our programming. This is our first app. We have discussed almost all the important things related to Spring application context container and all the basic things required to start with our programming. So in next demo we will discuss all the things in detail. We will discuss all the annotations related to HTTP request handling. We will discuss the REST control, REST standards also, how to program particular type of MUC application, how to develop API related to REST, and all those things will be discussed in next video. Thank you guys.